Hi everyone, welcome back. I hope you're enjoying these videos on the topic of image segmentation, especially using state-of-the-art algorithms and frameworks. And in fact, a few videos ago, I talked about Detectron, where we use the Detectron framework to execute mass Gaussian style instance segmentation. And in the last one, we looked at segment anything model and tried to train it or customize it for our specific purpose using our own images and annotations. And in the next couple of videos, I'm going to talk about YOLO and how you can customize it for your purpose, again, using your own data. So please do not forget to hit the subscribe button that you'll find down below. And while you're there, try to find the thanks button if you're feeling extra generous. Now, why am I recording this video? Well, I realized that at least working on different data sets, I tend to convert, my annotations into multiple formats. And I thought, okay, do people care if I record a video on that specific topic? I posed a question on LinkedIn and Twitter, and a few of you came back and said, yes, you exactly are going through the same scenario. Same situation where you spent a lot of time annotating, now you have binary masks, right? But new frameworks, new algorithms will come up. Like, how do you convert that into COCO style JSON? Maybe you want to use mass Gaussian, or you want to use YOLO, and now it requires another type of file format. So eventually it comes down to, hey, you have annotated in one way. How do you convert that into different ways? Now, again, there is so much we can cover because not every scenario is exactly the same. Because in my case, I have, let's say the example I'm going to show you with multiple classes, so you can easily convert that into binary. I just don't want to show you binary and then say, oh, there you go, you're done, But the real challenges, you have multiple classes. So I hope this gives you a nice overview. And again, depending on how your folder structure is and how you're storing your data, you will have to tweak parts of this unless you structure your data the way I'm going to show you. But either way, that's a lot of talking, 2 minutes or so. Let's go ahead and jump into actual content. And I hope you understand why I'm explaining, and not find this to be boring. If you find this to be boring, let me know in the comments, so I'll just shut up and show you the code. In which case, you may as well go to my GitHub and just download the code and not even watch this video. But I appreciate if you do watch these videos because some of the code, it's better explained than just taking the code and running it. Okay, now moving on. First of all, there are numerous annotation tools out there. I'm pretty sure you have tried some of those. And in fact, I did record a video in the past that's titled 10 Best Annotation Tools for Computer Vision. Go back, search for it. And this was about probably 8-9 months ago, because I recorded that one in 2022 at some point. So there may be new free tools, paid tools that are out there. Now, I'll talk about at least a couple of them. Like, first of all, there is something called Make Sense. I did talk about this last time. I occasionally use this if I don't have a large project. If I only have a handful of images that I would like to annotate, which is exactly what I did for my Detectron video. I took like these 5 images and I annotated multiple objects in these 5 images, and I have like 4 classes here. The green outline that you see there, they are cells, and the pink ones are labeled as cornicular vessels. And the blue, I believe, the green, the dark green outline is mitochondria, and the blue is, I forgot, one other class. But that's not the point. The thing is, there are tools out there, and they all work in a very similar way. Some provide like more annotation, more automation. I'm struggling for my words. Some provide more automation tools, meaning you annotate one, all the other ones kind of get highlighted. They work fine. You still have to go back and edit those because especially if you have images like the one that you see on the screen, it can be very challenging to for this program, for any of these programs, to automatically identify all. But again, in some cases, it can be good. For example, RoboFlow is a pretty good program. But before getting there, let me just flash this one screen where once you annotate this, you can export them in multiple formats. In this case, you can export them as COCO JSON file format, and you can work with these. So if you're starting from scratch, you can actually annotate directly in COCO JSON if you know that you're working with, for example, mass Gaussian style. But if you have binary, then that's the goal. That's what we'll cover right now. But once you have this COCO JSON and you don't like to code, you just want some tools to convert your annotations, then take these JSON format and then drag and drop them into RoboFlow. I'll show that briefly in the next video, but you can just drag and drop into RoboFlow, and it's smart. It actually detects these. It reads the JSON file and it actually puts the annotations. I tried this with binary masks and I don't think it understands, because binary masks is a bit more challenging, right? So you have one image and you have multiple masks for that same image. It's not a good way of describing your annotations. Maybe that's why they moved to JSON formats and other text file based formats for YOLO, for example. So either way, if you have COCO, then you want YOLO style, then just drag and drop into this RoboFlow. And I believe it lets you, when you click on the export dataset right there on the top right corner of that screenshot, you can see it can actually, you can choose whether you export it as code, meaning you can take the code snippet with your API key, put it in your code, and you're all done. Or you can download it so you can use it in future. So the goal for this video is to make sure I show you the process using a piece of code. That's it. Yeah, you don't need to interact with anything online, provided you have binary masks, which is most scientific data is available as binary, or I keep using the term binary. It can be multinary, meaning one image has certain pixel values for class number 1, another pixel values for class number 2, and so on. So a quick screenshot here. There is a lot of public data sets, whether it is binary, electron microscopy data set, or whatever you see on the screen. And the one that we're going to work with in the next couple of tutorials is, as you can see, it's binary, meaning each class has a specific pixel value. So this is our starting point, and based on that, how do we actually convert those? So this is the essence of this tutorial, and if you think this is what you're here for, then yes, let's go ahead and jump into the code. Okay, and let's do this in a step-by-step fashion, which is first let's convert our binary to COCO style, and then let's convert the COCO into the YOLO polygon style, which is basically a bunch of text files. Each text file corresponds to an image. But in the COCO style, we have a whole bunch of images. And again, I put this, it took a while for me to come up with this. Maybe there's an easier way, but in terms of drawing this, but I took this, basically, I think it's easier if I show you my file structure here. So as you can see, let me put this in the center and I'll digitally zoom in. Now you can see these are the files, the Python files that we're going to interact with today. And I have a directory called emplatelet, and within that directory I have input. I'll put other stuff in here as we go along, but what do I have in input? I have train images, train masks, val images, val masks, and you can add like test images. But these are the ones that we're working with. And what do I have in my train images? I have, as the name suggests, a bunch of images, right? That's it. I have nothing else. And train masks is corresponding masks for those images. So if I have train images, if I just open one of these images, let me say, leave it up here. And if I go back here, and now you see I have 4 different directories, one for each of the classes that I have in here. For example, let me open this alpha and let me open the first image. This first image, it corresponds to this, and you can see these are the alpha regions in this specific image. Similarly, if I go back and keep an eye on the file name, the file name for my image is exactly same as the file name for my mask here, and same as file name right here. It doesn't have to, that's how I stored it, and my code works if that's how you name your file names. Okay, if not, you obviously have to modify it. That's it. You have to find a way of aligning your images with the masks. It can be actually, one way to do that is read all the images and then sort them based on some metric and then all that stuff. I thought naming them exactly the same would be the easiest way. And this one shows all the cells, which is the outline, this entire region that you see. And similarly, I have mitochondria. I don't have many mitochondria in this image, and a lot of cornicular vessels. And this is how the structure is. And that's exactly what I'm trying to depict here Hopefully this makes sense. I have input directory, train images, train masks. You see how the file name is the same, image01.png, 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 and these are identified based on the folder directories, and that's what my class name is. This is common convention. I'm just spending a bit more time to make sure we are all on the same page when it comes to this, and this is the structure. Now, what are we going to do? First, we are going to convert these binary into COCO style format. How do we do that? I added a lot of text. I don't want to go through this. You can go through it at your own pace. But at a high level, for each of these binary masks, we are going to use the contours function in OpenCV and extract the contours, because they represent the boundaries of these objects, right? So the contours are going to tell us the boundary of each of these objects. And this boundary, we are going to convert that into a polygon, which is basically the coordinates of these boundaries. And we are going to add that for each of these images, each of these objects, into a JSON file. So that's at a high level. That is what's going on. And in addition to that, we're going to add a bit of metadata, like, okay, I mean, I'm not going to add any license, but you can if you want to add, and of course, images and categories and annotations and so on. Now, let's go ahead and have a quick look at the code. So first thing first, of course, these are the typical libraries that we're going to use. Glob to go through the images, and JSON, of course, to write our JSON file, and OS and CV to OpenCV. And you need to define your category IDs. In my case, I have 4 categories: alpha, cells, mito, and vessels. And I'm giving them each a name, like number 1, 2, 3, and 4. You can have only one class, in which case it's just a binary, right? So it's up to you how you want to add. And in my case, I'm looking for extension PNG. And again, if your images are .jpeg or whatever, go ahead and add. I hope your masks are not JPEG, because JPEGs are compressed, and usually you don't have this binary, because binary, we assume it's 0 to 55 or 0 and 1. But typically in JPEG, they're not that kind of binary. You have like some spread around 255, and so anyway, typically I recommend working with PNG, so or TIFFs. So there you go. Now we start our image ID and annotation ID, and we loop through each of these, as you can see down here. Yeah, I mean, again, you can go through the code, but we are going through each of those images, and we are kind of looking at the ID. And for each of these masks objects, we're going to get the contours. And in this case, these are just binary, so the setting of 0 to 255 threshold works great. So you don't have to change much of anything, but these are some of the things you need to work with if you're working with, for example, color annotations. First, extract individual annotations for individual classes and binarize the image. That is the best way to work with color annotations, if you're wondering how to work with those. And of course, yeah, now creating annotation for each of these, and we're going through each of the contours, and we are going to get a bounding box. We're going to get the area, add all of that information down here, which is your image ID, category ID, bounding box, area, segmentation. And these are all the aspects that are written to your JSON file. We'll open the JSON file and have a quick look once this is done. And yeah, I think that's that. And then you're actually processing the masks down here, and you're saving them into the JSON file, as you can see down here. Now I'm providing the paths of my train masks and JSON path, and my validation masks and the JSON path, and then where it's going to be stored. Now I'm choosing here to store my final JSON along with the images. And yeah, let's go ahead and run this. And where should it stores, right? I mean, it goes back. Let's go back to my train images. To this, it should add a JSON file at the end. So let's go ahead and run it. That was pretty fast, right? So did it actually do anything? Actually, you see, there is a JSON file right there. Now let's open the JSON file using Notepad++. Let's say, so there you go. This is how the annotations are. So annotation, area, what is the bounding box, category ID, and the segmentation right there. This is the polygon that you're actually seeing. And again, depending on, this is going to be a very long JSON file, because we have a lot of annotations. And if I'm successful to scroll all the way down, you'll see a bit more from this JSON file. So there you go. So now you see the file name, height and width, the ID right there, ID right here. So the ID for each of these file names and what's the height and width. And this ID gets, again, used. Study the JSON file, basically, if you have no clue what I'm talking about. And there you go. The categories, alpha is assigned a category of 1, cells is assigned a category of 2, and so on. And yeah, I think that's it. I don't have much to say. Now the question is, how do you trust that this actually did a good job? I mean, how do we know that this actually did a good job? Well, you can plot this. In fact, I've written some code to look at the YOLO annotations, but not for this. But I just mentioned in my presentation part, you can actually take this JSON file and your images and dump it into RoboFlow, for example, and then it will show you all the other annotations. Let's actually do that before jumping into the next step. Yeah. So let me open the browser and go to the RoboFlow web page. So I've already signed up for RoboFlow literally a few days ago because as you can see, this was edited 6 days ago, and I created a project called Junk so we can actually drop any images. So let's go ahead and open this. Again, this is not a RoboFlow tutorial, so don't worry. I mean, you just create your ID, free ID, and then create a project. The only thing is anything you dump here, I think if you don't pay, it becomes public data so others can access. That's a good way of keeping things free. But I'm just using it on all these non-proprietary images, of course. And let's go ahead and drop this train images folder. Remember, it has images and a JSON file. You see how it recognizes this. I'm still not importing because once you hit save and continue, that's when you actually import everything. But here, I just want to show you that our annotations are correctly picked up. And as you can see, this is where my cells are. This is where my vessels are, and the yellow thing is my toe, and the orange thing, if I can put my mouse on it, I don't know, why can't I? Yeah, it's I have to be careful and only pick these. Yeah, these are vessels, and you got the point. For some reason, I mean, I'm hovering over the cell, but it's a bit challenging for me to hover over this orangey stuff. But you got the idea. Everything seems to be fine. I mean, we just confirmed that as part of our JSON file. I'll leave this open in case we need to test this using something else. I don't know. But if you like this, you can go ahead and save and continue. You can export this into COCO and all that stuff, but that's not what you are here to see. You're here to see, okay, now you know how to go from binary to COCO JSON. And now let's actually see how we can take this information and then convert that into a YOLO style. And literally, I compiled this entire thing based on need because I never felt the need to work with YOLO. Now I'm working with YOLO, so I'm like, okay, how do I get my data? I don't want to annotate from scratch. I don't have that type of time. That's why I took the lazy route, because lazy people are the best at innovation. You know, you find a new easy shortcut to get things done, and that's how we got to this YOLO. COCO to YOLO polygon. Again, I put a lot of text, and the goal here is, again, the code transforms a data set of images into a format suitable for training our YOLO file. And by the way, an interesting note, I actually took this and I put it in ChatGPT, and I'm like, hey, can you describe what this actually does? It did such a horrible, crappy job, but it gave me enough text to just put it here and edit it. I could have written this from scratch, and it would have taken the same amount of time. I think there's still long ways for ChatGPT to go for us to rely on it 100%, whether it is in compiling code or writing text. I also tried to write some code using ChatGPT. I know I'm going on a tangent, but I'm just sharing my experience. I also tried doing that. I thought it would get me at least 50, 60, 70% there, and I can kind of edit other things. In a few tasks, it just got me 20% there, 30% there. And then it's like, it gives me some crappy code, and it says like, okay, I'm like, hey, that library doesn't exist. And then it's like, oh, my apologies. And then it gives me something else. I'm like, okay, that doesn't exist. Okay, that library exists, but this function doesn't exist. This method doesn't exist, right? And it wasted so much of my time. I'm like, okay, it's not there. It thinks that it's giving me some code that I can rely on. If you guys have better experience, I would love to know about it. But I only had crappy experience with that. But when it comes to annotating, summarizing, adding comments and all that kind of stuff, it's a good assistant, I should say. Okay, I use that to some of this to text, to generate some of this text, and then I edit it, but I hope this text summarizes everything that we are about to do. So again, we are going to take the JSON file, right, that has all the annotations. But in here, did I include? Yeah, the structure of YOLO annotation is for every image, you have a text file that contains all the annotations for that image. And the first one, the first column, is going to be class ID. Your class ID can be 0, 1, 2, 3 in our case, right? And then it's going to have a normalized polygon coordinate number 1, coordinate number 2. So the next things are all basically the annotations that describe that class ID. So that's it. That's as simple. So we need to take our JSON file as input, and we need to look at all the, where the files are, and we need to just copy. In this case, I chose to copy all the PNG images from the input directory into a YOLO directory. So I don't. So all my stuff is at one place. So I did a little few things that match the way I like to organize my files, but you'll see how the end result is going to be. Now, in addition to the JSON file, in addition to the text annotation files, you also need the YAML file, configuration file for YOLO. And I added another function to actually summarize this, to write this. So we have everything ready for our tutorials in the next video and the video after that, where we train our own custom YOLO-based instant segmentation model. So I think this is good background. And again, function to convert to YOLO. And it's pretty straightforward. Again, it took a while for me to kind of figure out aspects of this. So I'm not saying you can come up with this code like within in one sitting. It took me a few weeks for me to kind of a few weeks of each day, let's say half an hour to 45 minutes thinking about it. But finally I have it, and I'm gladly sharing it with you. Look for the description down. For the link under the description down below the video. And creating a YAML file. YAML file is nothing but, hey, these are the number of classes I have, and these are the names, and this is the path for my test directory, train directory, and validation directory. So it's pretty simple. So this is very easy to write, as you can see. Okay, now let's get down. So let's go ahead and convert our training images. If needed, should go process training dataset. We always have training dataset. We may not have validation dataset. So process validation dataset if needed, but you process training dataset, and I'm creating a YAML configuration file. So let's go ahead. I should have included some print statements so it shows me how many annotations. I think for this one I did not. For the previous one, you see we have some report, and you can enhance this code if you want. I think this just, so I forgot to do that. I was excited to record this video, forgot to add the print statements, but either way, now if I go back, you see how I have a new directory called YOLO dataset, because this is what we are creating. And I am copying all my training images into train directory images right here. And all the labels that we just created, they get stored under labels right here, as you can see. And if I open these labels, you should see the first column is the class ID. If I go down, we may see different class IDs. If I scroll down, I saw one like right here, right? This is one, so a different class ID. And we may have 2s and 3s occasionally showing up. So as you can tell, we have one class like overrepresented in this case compared to in this data set compared to others. So there is like 2, there is 3 somewhere else. So these are all classes, and these are all annotations or the coordinates for this normalized polygon. Okay, so we have these, and again, you can drag this into RoboFlow, or in my case, I've written this display YOLO annotations because I wasn't sure, like, is this right? And every time I don't want to go while I'm troubleshooting, go to RoboFlow, and also RoboFlow, it's not really clear if it's picking up the right region. So I just wrote a few lines of code here. Again, you'll find that in the same place where everything else is shared. So yeah, I think this is good, right? We have YOLO dataset, and we have train and valid, and you see the YAML file. Let's drag the YAML file right here. And names, of the classes here and number of classes and where the test and train. So when you are going to, for example, next or in 2 videos from now, we're gonna train this on Google Colab. Then we need to change the exact location where the train and validation is, but the structure is all ready for you guys. Okay, so that, and we are about to display the YOLO annotation. So basically we are looking at this. You can do train or valid, pick one of these. What did I pick? I picked like one of these images, train 4, train04.txt, and this is in the train folder. So let's go ahead and make sure that file really exists. So 0404 right here, that one. And we're going to take the labels of the 04 and we are going to display that onto an image. So let's go ahead and run this. And if I go to plots, you see, there you go. Let me expand this because this is where we are ending this video, so we can make sure we are looking at this pretty annotations. Now you can clearly see all the cells and individual organelles in here represented in different color outlines. So I hope at least some of you will benefit from this. And again, please do not forget to hit the subscribe button and keep learning, and leave comments if you want any such content to be covered in future. I may not have time to respond to every comment, but I definitely make sure I browse through them in the morning, the first thing in the morning, and make sure I take some notes in terms of what people are asking for, and look at some trends in these, and just record videos like these. Well, this one directly came from someone asking a question, I believe on Twitter or LinkedIn. I thought I was the only one, but apparently others also go through these type of issues. So I should end this video now. Okay, guys, thank you very much, and let's meet again in a couple of weeks discussing YOLO. Bye.